Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 4, Thermochemistry Part 4. And here are our objectives for this video. Pause here. So this is just a term to describe something that we've already conceptually discussed, which is a state function. State functions are properties that depend only on the present state or something that is path independent. So that's why we can use Hess's law, because enthalpy is path independent. It doesn't matter how we got from our reactants to our products. There might be 18 different mechanisms or pathways that we can get from point A to point B. It doesn't matter which one we take. That's why we can use Hess's law. There are things that are not state functions like work or heat, so we could not apply Hess's law to those. We're also just going to see that it doesn't really make sense to apply the same sort of ideas of Hess's law to those things. But you'll see that we're applying the principles of Hess's law to other sorts of quantities, especially in chapter 17 of your textbook. Pause here. So what if we can't use Hess's law to determine the delta H of a reaction? Then you might want to use what's called the standard enthalpy of formation. So the standard enthalpy of formation of a compound, we just give it that symbol. The F is for formation, and the naught, the 0, just means it's at standard state. We'll talk more about what standard state means later in the video. So that is a change of enthalpy that accompanies the formation of 1 mole of a compound from its elements. Pause here. Standard enthalpies of formation, these are values that you can look up. There is a table of them in your textbook. Usually the values will be included in the question if you need to, aside from the ones that are in your book, but in the AP exam, the values are included with the question if you need them. And many substances have known values, so that makes it super easy. So this is an example. This is showing the formation of NO2 from its reactants. It's always for 1 mole of product. That's why I needed the 1/2 before the N2 with the reactants. And then that delta H value is known, and therefore I could actually use this to determine my overall, if NO2 is a reactant or product, I could use that 34 kilojoules per mole to help me determine delta H of the reaction. Pause here. So knowing that the delta H for a formation is 0, if something is in its standard state, that formula looks really, really complex. All it means is products minus reactants and use the number of moles. So I'll show you what I mean by this in the next example. Pause here. All right. So remember, it is products minus reactants. That's really what you need to remember about this. So I have 4 moles of NO2. Each one has an enthalpy of 34 kilojoules per mole. And I have 6 moles of water. Each mole of water is negative 286. And then it's minus reactants. So minus 4 times negative 46. Minus 7 times 0 because oxygen is in its standard state. You don't really need to worry about sig figs with these things because these are all what's considered to be like constants of sorts. So I wouldn't really worry about those here. I got negative 1396. So this is a very exothermic reaction. And all of the problems of this variety are typically going to be this straightforward. Pause here. So we talked about standard states, and so this is just going into a little bit more detail about it. This is not something that really pops up as a question. This is more just for your own general knowledge. We'll talk about non-standard states more when we talk about electrochemistry anyway. But an element is in its standard state if pressure is 1 atm and temperature is 298 K. That's about room temperature. And then the most important thing is it is in the allotrope form that is common. So oxygen is O2, it's not O. Any of the Hunkelbriefs are going to be diatomic. By and large, those are the only ones you need to know off the top of your head. And then a compound is in its standard state if pressure is 1 atm, temperature is 298 K, same as with an element. But if it's a part of a solution, the solution is 1 molar. And then here are our practice problems for this video. Thank you so much for watching and have a great night.